Hi children, how are you? All of you welcome to our channel Math Insights. In this important video I am going to start another new chapter called Sequences and Series. This chapter is appearing in CBSE class 11 and the chapter number is 9. This is very important and we will discuss these sequences and series in detail. Shall we? First, you have to discuss the term sequence. If you search the meaning of the word sequence in the English dictionary, you will find the definition that arrangement of numbers in a particular order. Simple definition. So, a sequence is nothing but arrangement of numbers in a particular order, a definite order and a particular rule. Then that arrangement is called sequence. Okay? See, I am taking the terms of sequence are represented by using A1, A2, A3 and so on AN. A1, A2, A3 and so on AN. This is the letters, these are the letters which are used to represent the terms of the sequence. I said that sequence is nothing but arrangement of numbers according to a definite rule or a particular law. Suppose I am taking an example 2, 3, 5, 7, 11 and so on. All of you know what are these numbers? These numbers are prime numbers 2, 3, 5, 7, 11 and so on. You cannot find any formula to say the next number of this sequence. You can simply say that 13. How you are saying 13 without having any formula? Means there is a rule. A prime number is a number which cannot have any other factors except 1 and itself. In all these numbers, you have the numbers which are having only 1 and themselves as their factors. Hence, you are saying you are following a rule. Similarly, if you see 2, 4, 6, 8 and so on. See, the formula for this is 2n. If you put n is equals to 1, you will get the first term. If you substitute n is equals to 2, n is nothing but term number. If you want to get term number 2, you have to substitute n is equals to 2, and similarly if you substitute n is equals to 3, you will get this is 2, this is 4, this is 6. So you are getting all the terms. It's again very simple. Sequence is nothing but arrangement of numbers and you are in a position to identify the first, second, whatever the term number. I will give you the real life examples. The human population is increasing year by year. In this year, its number is something. In the next year, its number will increase. If you take India, in India generally population has been increasing, that's why the numbers will increase. Would you find any formula for this? No. First, it may have 1 lakh suppose, then 1.5 lakh, then next is 3 lakh, 4 lakh. So in this way, we will have the numbers. Arrangement is according to increase. Similarly, this is also one arrangement, definite order. So these are called the terms of the sequence 2, 3, 5, 7, 11 and 13. See A1, A2, A3 and so on AN. A1 is the first term of the sequence, A2 second term, A3 third term and so on. AN is the nth term of the sequence. Now types of sequences. If any sequence contains finite numbers in it, then that is said to be a finite sequence. And if the sequence contains infinite number of terms, then that is said to be infinite sequence. Okay, sequences are generally represented as an by greater than and less than. If you have this symbol an means nth term, then that is said to be a sequence. Now I am going to take another type of a particular sequence. See, I am taking 1, okay, 2, 3, 5, 8, and this is 13 and so on. Do you find any formula for this? No, you could not find any formula, but this arrangement is in relation to recurrence. Suppose if you accept the first and second terms, let the first term is a1, second term is a2, then this is a3. If you observe, a1 is equals to a2 is equals to 1, and a3 is obtained by adding, a3 means 2, by adding the first term and second term. Similarly, a4 is obtained. a4 is nothing but term number 4. 3 is obtained by adding 2 and 1. So a4 is equals to a2 plus a3. Similarly, if you write the general term, an is equals to an minus 2 plus an minus 1, where n is greater than 2. If n is equals to 2, suppose it will become a0, which is not containing in the sequence. So an is equals to an minus 2 plus an minus 1. This sequence particularly is called Fibonacci sequence. Fibonacci, Fibonacci. Fibonacci is name of a mathematician. After he discovered this sequence, this sequence became Fibonacci sequence. From these examples, you may define the sequence in another definition also. Sequence is nothing but a function whose domain is a natural number or a subset of it. So again I am saying sequence is also defined as a function whose domain is set of natural numbers or any subset to natural numbers. Another important term is series. After having the knowledge of sequence, it is very easy to define what is meant by a series. Series is nothing but addition of numbers of sequence. If you put plus among the terms of a sequence, then that will become a series. Suppose I am taking a1, a2, a3, a4 and so on an. These are the terms of a sequence. If I will add all these by putting plus among them, then that will become a series, right or not? Again, series are two types depending on the number of terms it contains. If the series is having finite number of terms, then that is called a finite series, and if it contains infinite number of terms in it, or you are going to add infinite number of terms of a sequence, then that is said to be infinite sequence. Okay, I want to write, you may write all these terms in a compact form by using a symbol called sigma. Sigma is a Greek letter which is used to represent addition of terms. See, instead of writing all these terms, I will write an. That means the general term or the last term of the series by putting sigma. This is read as sigma. You have to mention the range of n from which number to which number. See, n is ranging, otherwise you may write ak, where k is starting from 1 and ending at n. See, when you place k is equals to 1, it will become a1. Since sigma is there, we have to put plus, and when k is equals to 2, it will become a2. Similarly, sigma is there, means addition, a2, a3 plus and so on. So this is called compact form or sigma notation. Okay, sigma notation. So now I am taking the examples which were given in the textbook. See, this is example 2, this is example 1. Actually, I am solving example 1 first. See what they are asking, write first 3 terms in each of the following sequence defined by, means this is the formula for nth term. An is equals to 2n plus 5 and here an is equals to n minus 3 by 4. If you want to get the terms of this sequence, simply substitute n is equals to 1, then you will get the first term, n is equals to second term, n is equals to the third term. I am solving this one, I am leaving this for you, otherwise I will solve this one. Okay, first simple this one, solving this one, put n is equals to 1, therefore you will get a1. So in the place of n, I am substituting 1, 2 into 1 plus 5, that is 2 1s are 2 plus 5, which is equals to 7. If you put n is equals to 2, you will get the second term. In the nth term also have to put 2 into 2 plus 5, which is equals to 4, 2 to 4 plus 5, that is equals to 9. Next, n is equals to 3, then a3 will become, here also we have to put n is equals to 3, 2 into 3 plus 5, 2 3s are 6 plus 5, that is equals to 11. Therefore 3 terms are first one is, what is this, 7, okay, 9, 11. Now it is easy, as I solved this one, take this one and find the 3 terms of this sequence. Coming to the example 1, what is the 20th term of the sequence defined by? See, they have given you nth term. Instead of asking the first 3 terms or first 5 terms, they are asking a particular term, that is term number 20. See, I am solving this, okay, I am solving this. An is equals to n minus 1 into 2 minus n into 3 plus n. If you put n is equals 20, you will get 20th term, very simple also. So a20 means 20 minus 1 into 2 minus 20 into 3 plus 20. Wherever n is there, simply I am substituting n is equals to 20. So 20 minus 1 is nothing but 19. See, 2 minus 20 minus 18, okay, minus is there, putting in bracket, into 23. See, if you multiply all this, you will get, see, minus 19 into 18 into 23. If you multiply all these 3 numbers, then you will get the answer, that is the 20th term of the given sequence. Is it easy or not? Definitely they will become easy if you solve some more problems in the exercise. Shall we solve the problems in the exercise 9.1? I have taken the problems from exercise 9.1, which are related to sequences and series. What they are asking, the first one, write the first 5 terms of the sequence. These problems are very similar, which we solved as examples. I have not taken every problem because everything is easy. Whatever somewhat difficult, I have taken. 5th problem is somewhat difficult, that's why I have taken. Write the first 5 terms of the sequence whose nth term is minus 1 whole power n minus 1 into 5 power n plus 1. I am solving 5th term here. For this I am dividing the board into 2 parts. See, I want the first one, therefore put n is equals to 1, that is equals to minus 1 whole power 1 minus 1 into 5 power 1 plus 1. See, minus 1 whole power 0, anything power 0 except 0 power 0 is 1. Therefore, minus 1 whole power 0 is 1. 1 into this will become 1 plus 1 2, that is equals to 2. 5 square means 25. So 25 into 1 will become 25. Now I want second term, means put n is equals to 2, then you will get the second term. Therefore minus 1 whole power 2 minus 1 into 5 power 2 plus 1. See, again minus 1 whole power 1, 2 minus 1 is 1, minus 1 it will become minus 1 into 5 power 3. 5 power 3 is nothing but 125. Therefore it is minus 125. Coming to the third term, means putting n is equals to 3, you will get the third term. Therefore minus 1 whole power 3 minus 1 into 5 power 3 plus 1, that is equals to, again minus 1 whole power 3 minus 1 will become minus 1 whole square. See, whenever negative is having even number as its index, then it will become plus. Therefore you will get plus value here, and this will become 5 power 4. 5 power 4 is nothing but 625. So the three terms are 25 comma minus 125 comma 625. These are the required three terms of the sequence whose nth term is given. Coming to the second one, here also they have given 4 or 5 problems, but whichever is confusing, I have taken those problems and I will solve them. Eighth problem, find the indicated terms of the sequence. Indicated means they are asking the particular term number of the sequence by giving nth term. Here in this case, nth term is an. So eighth problem here. Nth term is n square by 2 power n. Now I have to find a7, means substitute n is equals to 7, then you will get your required seventh term. a7 is equals to 7 square by 2 power 7. 7 square is nothing but 49, and 2 power 7, 2 power 5 is 32, 2 power 6 is 64, 128. So this is 128. So a7 means seventh term of the sequence whose nth term is given. Okay, coming to ninth problem. Ninth is also same. They have given nth term of the sequence. Now they are asking ninth term. Similarly, you have to replace n is equals to 9 in the nth term, then you will get the ninth term. Therefore a9 is equals to minus 1 whole power 9 minus 1, n minus 1 into n cube. What is n? 9 cube, right? Here minus 1 whole power 9 minus 1, 8, which is an even number. Therefore if the index is even number, this minus will not come again. Therefore it will become 1. 1 into 9 cube is nothing but 729. Otherwise, first to do 9 square, which is equals to 81 into 9. So 9 ones are 9, 9 8 is 72. So this is ninth term of the sequence. All problems are like this. Solve all problems in exercise 9.1, which will give us confidence in solving further problems. Now I will take next problem of the exercise. This is the next problem. In this problem they are asking write first 5 terms of the following sequences. They have given 3 problems, but I have taken only 2 and I am leaving you to practice that. Do yourself. See, they are giving a1 means first term of the sequence, and they have given nth term also for all n greater than 1. Why? Because they are particularly saying n is greater than 1. They have given you the first term, and also if you take n is equals to 1, this will become 1 minus 1, 0, means it is not a term number. Okay, we are starting term number from a1. right? So I am solving the 11th question and I will solve 13th question here. 12th question I am leaving for you for your practice. Okay, see, an is given, an is equals to 3an minus 1 plus 2. If you want the first 5 terms means they have given you already the first term, so it is enough if you find the next 4 terms. Is it okay? So I want the second term now, I don't want the first term. So 3 into a, okay, 2 minus 1 plus 2, which is equals to 3a1 plus 2. a1 is already given as 3, therefore that is 3 into 3 plus 2, that is 3 3 is 9 plus 2, which is equals to 11. Similarly, a3, third term, you have to use the nth term for every term. So 3 into a into 3 minus 1 2 plus 2. Where is a2, second term? a2 is calculated as 11, so that is equals to 3 into 11 plus 2. 11 3 is a 33, 33 plus 2 will become 35. So in this manner you can calculate whatever the number of terms you want. It will become very easy if you have the nth term. Now coming to the 13th question, I am leaving a4 and a5 to you. Coming to the 13th question, in the 13th question they have given you first second terms also, and they define the nth term as an is equals to an minus 1 minus 1, where n is greater than 2 here. What they are saying, n is equals to 1, n is equals to already given first and second terms, therefore starting with the third term you have to find the next 3 terms, then total terms will become first 5, right? I am starting with a3. a3 means a3 minus 1 will become 2 minus 1. They have already given what is second term, that is a2. a2 is equals to 2 minus 1, which is equals to 3, therefore which is equals to 1, therefore a3 is equals to 1. Now if you want to find a4 is equals to, in the nth term you are putting n is equals to 4, therefore here a4 minus 1, which is equals to a3 minus 1. a3 means third term, which is already calculated as 1, therefore it will become 1 minus 1 0. In this way you may calculate the next term also, then there will be first 5 terms of the given sequence whose nth term is. This is the last problem, the exercise 9.1 related to sequences and series. They are saying problem number 14, Fibonacci sequence is defined by. We already come across the definition of Fibonacci series whose first and second terms are 1, then the next terms are obtained by adding its previous 2 terms. So 1 plus 1 became 2, 1 plus 2 became 3, like that. Now they are asking the ratio of an plus 1th term to nth term for n is equals to 1 2 3 4. Now I am taking for n is equals to 1, means it will become a1 plus 1 by a1, that is equals to a2 by a1. This is nothing but ratio of second term to first term. They have already given a2 a1 both are equals to 1, therefore 1 by 1, which is equals to 1. Next, if you put n is equals to 2, then it will become a3, 2 plus 1 become a3 by a2, means this is the ratio of third term to second term. But we don't have third term, you have the second term whose value is 1. So first find third term, means here you are finding third term by using the given formula for nth term. a3 is equals to a3 minus 1 2, a2 plus 3 minus 2 a1. So a3 is nothing but sum of its previous two terms. a3 for its previous two terms a1 and a2. Already values are given. 1 plus 1, that is equals to 1 plus 1, which is equals to 2. If you know the third term, then write its value here, and a2 is 1, that is equals to 2. For n is equals to 3, it will become a4 by a3. You know the value of a3, which is third term, but we don't know value of fourth term. Now going to find fourth term. a4 is equals to, by using the nth term, a4 minus 1, 3, a3 plus a2. You know a2 value and also a3 value. a3 value is 2 plus a2 value is 1. Therefore, fourth term of the sequence, Fibonacci sequence, is 3. Therefore, this is 3 by a3 is equals to 2. So, the ratio is 3 by 2. So, in this way, you can calculate the ratio of any particular values of n. Okay, I think all these problems which are related to sequences and series are clear, my dear students. If you like video, don't forget to subscribe to my channel. I will make more videos. After this, I will make the continuous video on arithmetic progression, geometric progression, and I will complete the chapter within 2 or 3 videos. So until then, have a nice day. Be safe. Don't go away unnecessarily. Be indoor. Save the nation. Save your family. Save the community. Thank you.